Alright guys, in this lesson we will continue practicing solving and graphing polynomial inequalities. Watch out though, because in this lesson several of the zeros will be decimals. So you won't be able to find them by factoring or using the table of your TI-30. If that happens, it's okay. Just go to wolframalpha.com and type the functions in to find the zeros. Alright, if you have a graphing calculator, in class we're going to use graphing calculators to find those zeros. But if you don't have a graphing calculator at home, then use wolframalpha.com. And I'll show you how. And remember, we have two methods to do this. We can use test values to check each interval to find which intervals have the solutions. Or we can draw a sketch of the polynomial and just observe where the polynomial is above the x-axis for greater than 0 or below the x-axis for less than 0. I'm going to try to do some of the problems by method 1 and some of the problems by method 2 so you can see both methods. Alright, let's always start by getting 0 on one side. So let's definitely subtract 2 from both sides. So that's going to give us, so we'll have x to the third power minus 2x squared minus 3x. Now both of these cancel out, so I'm going to have greater than 0. Alright, so I would try to factor this. I see that there is a common factor, a GCF, so let's go ahead and pull that out. Okay, so I will pull out the common factor of x. Alright, and I'm going to see what's left behind. So that's going to leave behind x squared minus 2x minus 3. Alright, and of course we would go ahead and try to factor this trinomial, because maybe it is. So let's see, if this is going to be factorable, it would be x and x. 3 can only factor as 3 times 1. Now to make a negative 2, right, because in my mind I'm thinking this, the inner plus outer must equal the middle. So inner I have 3x and outer I have 1x. If I'm going to make a middle of negative 2, I need a negative 3 and a positive 1. So there's my negative 3 and there's my positive 1. That also gives me the negative 3 that I need. Negative times a positive is a negative. So this is factored correctly. Okay, let's see, so let me move that out of the way and bring down my x. Okay, so now this is factored, but I want to find the zeros of this function, so I'm definitely going to go ahead and set each of these factors equal to 0 right now. Okay, so that will give me x equals 0 from that one. And then if I set x minus 3 equals 0 and x plus 1 equals 0, that's going to give me x equals 3 and x equals negative 1. Okay, so these are the 3 zeros of the function, and looking at the degree, I was looking for all 3 of my zeros, and I have them all. Alright, so we need to decide if we're going to do method 1 or method 2. Are we going to use test values, or are we going to use the sketch? For this one, I'm going to use the sketch instead of test values. So if you're going to use the sketch method, you're going to have to draw 2 graphs. Alright, one for your work, where we graph the polynomial, and then another one for your final answer where you do the intervals. Okay, so here's our work graph, and to, obviously I went ahead and I'm getting ready to graph my zeros. So my zeros are here on the number line. Okay, this is where the function equals 0. Alright, we'll come back to that. Now, I'm looking at this polynomial right here. Okay, the one as soon as we got 0 on one side. That's what I'm sort of using. This function is a cubic. So, and also I see that the leading coefficient is positive. So I know that in general the shape of this type of graph is like this. Okay, now I'm looking at the zeros, and I see that there aren't any repeated roots, so I don't expect any bouncing or any inflections. So the graph should go through each one of these points and make this sort of an N shape. Alright, so I'm just going to draw that N shape as best I can through these points. So something like this would be good. Okay, and then I decide, do I want the part that's above the x-axis or the part that's below the x-axis? And of course, because I want to know where the function is greater than 0, then I'm interested in the part of the graph that is above the x-axis. Okay, so that's this part right here. And notice I'm not including the endpoints. Alright, because I don't want it to be equal to 0, I want it greater than 0. So I'm not including the endpoints. Alright, so these green parts of the graph represent my solutions. Okay, so all I want are the x values though. So that's what I'm going to draw on my solution graph. So I have solutions between -1 and 0, and then I have solutions x values greater than 3. So now I will go ahead and draw those. Okay, so open circles to not include the endpoints, and we had solutions between -1 and 0, and we had solutions greater than 3. Okay, interval notation. Okay, round parentheses because we don't want to include the endpoints. So -1 to 0 from this segment, union 3 to infinity for this part of the solution set. Okay, so that is the answer to problem number 1. Okay, now let's take a look at problem number 2. Okay, there are a couple different ways to solve this one. Now, if I did what I normally do and I were to subtract 4 from both sides, because that's usually our first step, get 0 on one side. So I'm still going to do that. Okay, that's going to give me x to the 3rd power minus 4 is greater than 0. Okay, so I have this. Now it would be time to factor, but we can't factor this. There's no, we don't have any technique to factor this. So I'm going to go ahead and take a look at the table of my TI-30, see if I can find any zeros. Alright, so here I have it all typed in. Let's go ahead and take a look. I usually start at -10 because it rarely goes beyond that. Okay, so here we are in the negatives, so I'm looking for it to change over to positive as I'm scrolling down. Okay, it just changed from negative to positive. There is a 0 in there somewhere, but it's not on this chart. Now I'm looking for it to change back to negative again. Okay, and it doesn't. So there was one 0 that was visible on this chart only in the fact that it switched from negative to positive. So let's go back to see that again for a second. Alright, there's a 0 here between 1 and 2, somewhere between 1 and 2, but we don't know what it is. So the calculator's not helping us, it's not factorable, so we could go to wolframalpha.com right now. However, there is another way to solve this problem, because so we don't really need Wolfram Alpha for this problem, and here's why. We only have one kind of x. We have x to the third power. There's no x squared or x. It's just x to the third power. Whenever there's only one type, you can just set it equal to 0 and use roots. In this case, cube root. So if I set x to the third power minus 4 equal to 0, I can solve this using radicals. So I would add 4 to both sides. So this is really putting it more back the way it was in the beginning. So that's going to give me x to the third power equals 4. Now, so if I want to get x, I could take the cube root of both sides. Okay, so I could take the cube root of the left and the cube root of the right. You don't need to do plus or minus when it's an odd root, alright? It's just going to be one number, one answer. Okay, so the cube root of x to the third power is just x. Alright, these two cancel each other out. So I just need to figure out what the cube root of 4 is, just so I can place it on my calculator. And for this problem, I'm definitely going to use the test value method. I'm going to use method 1. Alright, I'm going to find the zeros, but then I'm going to use test values in each interval. So look out for that. Method 1 this time. Okay, so the cube root of 4. So here's how you do cube root on your TI-30. Okay, for cube root, first you type the number 3. Okay, I guess I should show you what I'm doing. Alright, so first you type the number 3, and then if you can see above the caret, it has this x root. So that's what I want. So I'm going to hit second caret, and that turns this into the cube root. So I can put the 4, and now I'm doing the cube root of 4. So if I hit enter, so I see that rounding to the nearest tenth, this is approximately 1.6. So that's what I'm going to use. Okay, so this is approximately 1.6. Okay, so since I'm going to use the test value method, I don't need two graphs. So I'm just going to go straight for the answer graph. Alright, so here's my answer graph. I always like to put 0 on here somewhere. So let's say that's 0. And then somewhere over here will be, and just for fun, I'm going to go ahead and put the cube root of 4, because that's exactly what it is the cube root of 4. But just so you and I can remember, this was, what did we say, approximately 1.6. Okay, so I'll just put that next to it. Alright, this is about 1.6. Okay, I'm going to graph this 0 as an open circle, because it's just greater than. I don't want to include equal to. So open circle. So I only have the 1, 0. That's it. So this 1, 0 divides the number line into two zones. Okay, I've got this yellow zone on the left, and I've got this blue zone on the right. Okay, so this would be a great problem to use the test values, because I only need two test values and I can make sure that they are integers. Okay, so for the yellow zone, I'm going to use a test value of 0. Okay, so 0 will be my test value for the yellow zone. For the blue zone, remember that this is approximately 1.6, so I could just use 2 or 3 or just anything bigger than 1.6, but I'm just going to use 2. So these will be my 2 test values. Okay, alright, so 0 and 2. So I'm going to keep this in my work area though. So I'm going to find f of 0 right now. Now I already have this function in my calculator, so let's just use it. Okay, so if I want to find f of 0, sure, why not just let it start at 0. Okay, so f of 0 is -4. Okay, so let's just use the calculator for that. So f of 0 is -4. Okay, so the question is that greater than 0? Okay, is it greater than 0? No. Okay, -4 is not greater than 0. Okay, so that means the yellow zone is not where the solutions are. Okay, so we can forget about the yellow zone and just leave that blank. Okay, now let's test the blue zone. Representing the blue zone, we're doing f at 2. Okay, so let's see. So the value of the function at 2 is, oh, well, it's right there. It's 4. Okay, and then I ask myself again, is that greater than 0? And remember, I'm getting the greater than 0 from right here. Is that greater than 0? Well, yes. Yes, it is greater than 0. Okay, that means 2 is a solution to the inequality, which means all of these blue values are solutions. And I will show that all of the blue zone blue values are solutions by drawing an arrow to the right of 1.6. And that's it. So that is the solution graph, and I can write the interval for this from, you know, you can put 1.6 if you want. Okay, from 1.6 to infinity. Alright, but if you wanted to put the cube root of 4 right there, that would be great also. So either way, that is the answer. Alright, that's it. So that's how you would do number 2 using the test value method.